Well, thanks everyone for lasting out towards almost the end of the day. At least this is my last and most favorite introduction that I'm going to do. Charmee actually caught my eye when she attended a few of our meetups back in the early days. We started the Washington, D.C. Apache Spark Interactive over 3 years ago, and now we have over 2,000 members. And Charmee would attend our meetups, and she would hammer our speakers with these tough questions. And I'm like, oh my gosh, I'm going to have to get her to talk. So I'm really excited that she's back again here for Spark Saturday. And I hope all you guys went to the Women in Big Data table, right? She's also the only woman speaker here at Spark Saturday. So let's give a round just for that, right? Let's support our women in big data, all right? All right, here's a short and sweet intro of Charmee Patel, who's a product architect with Sentosa. She is working on a behavioral analytics application that can help people understand the online and offline behavior of individuals. Charmee's been involved in big data and distributed processing for most of her career, and she's badass, you know? So, and here's Charmee. Thanks so much.
Thanks, Donna. Oops. I wouldn't really describe myself that way, but thank you. So, at Sentosa, we work with a lot of our customers, and we've built an application that helps our customers really take their machine learning models from zero to production ready literally in days and not in months. So I wanted to take this time and talk a little bit about how we do that within our application. Before we go there, though, just wanted to give a brief overview of what we do as a company. Sentosa is a predictive behavioral analytics application. We help our customers take behavioral data from several different sources, overlay them with whatever enterprise data they have in their systems, give them some sort of a framework where they can answer a lot of behavioral questions, do a lot of behavioral modeling on top of that, and really help our customers move faster quite a bit. We've had customers who've taken 6 months just bringing in one set of data, and we go install, and within a few weeks, we actually have everything up and running for them. One other thing, we not only run in our own Hadoop platform, but our application basically gets installed in our customers' big data application. So it gets installed on any Hadoop platform. It also runs on any cloud, Google Cloud, AWS. We're cloud agnostic. So we can do all of these things, prepare the data, put the data back in the customer's enterprise data lake in their choice of system. We're based in Washington, D.C. We're in Herndon, actually, and then we also have a sister office in London where we have quite a few customers. So before I talk about anything on how Sentosa brings any advantages, I wanted to talk a little bit about what we see, how the models are built today in majority of the organizations. So let's start with this. Let's say there's this business user who has an idea that they want to be able to do something. They talk to somebody who's a business analyst, understands the domain a little bit better, also is closer to the tools, who then talks to a data scientist, who goes to the enterprise data lake, has a bunch of data sitting in their enterprise data lake. Now the data scientist writes a bunch of custom machine learning data pipelines, some notebooks, and at that point, they're done. And then they bring in the data engineer. When they bring in the data engineer, they have to explain everything. They have to go over the entire flow. They have to explain what it is that they're doing, what it means for the data engineer when they want to put that model into production. And that is where the long time to value cycles come in. Also, it means that you need a data engineer who is who is quite familiar with machine learning frameworks. You need a data scientist that can not only do modeling, but can also do a lot of data munging type of, a lot of SQL-like activities, data transformations. And overall, it takes a lot faster. So does anybody resonate with this process today? Is this accurate? So how do we really make this faster? So there's several ways that companies have tackled this. One of them is the notebook-style applications, where you can say, I'm a data engineer or I'm a data scientist. I come in, I start writing my code, and once I'm done, I don't need to explain it to anybody. I'm just going to put my code on schedule and it will start running. That's great, but many times your exploration code is not really your production code because they don't really have the same performance requirements. And then every so often you'll have common techniques, common code patterns that you're applying again and again, and you end up needing to copy paste that again and again. And that's not it's a very good way to get started, but that doesn't really help you over time have a very neat ecosystem of all of your data. Same thing with general purpose ETL tools. And a lot of the ETL tools are getting in the space where they want to run your Spark code. They're not great for exploration, but they also have the same problem. As soon as you want to share some common code patterns, some common code, you're going to basically just keep copy pasting your code or your DAGs everywhere. And over time, that becomes a nightmare to manage. There's the third approach that a lot of companies have taken, which is go look at a particular business vertical, look at a particular domain, inject some domain understanding in what it is that you're doing. Now, once you have that domain understanding, build a framework on top of it, and then build some components that are meant to solve some of those business problems. And that allows you to actually model a lot faster, run a lot faster. For Sentosa, for the behavioral analytics that we provide to our customers, what we did was we modeled everything as some sort of an event that happened that is revolving around a customer or an entity. The event happened at a particular time, and there's a bunch of attributes associated to those events. Now, once we can model this in this sense, now we can build a lot of components that run on top of these events that allow us to do a lot faster data munging, a lot faster machine learning transformation, a lot faster modeling. And in general, it allows our customers to really iterate so fast that even if they fail on the very first approach, they literally have something, at least an experimental model in a couple of days. So what does behavioral data really mean? So to give an example, I started with this company, let's say a fictitious company, ABC, that has a lot of different faces to the external world. They have a mobile web, they have a mobile app, they have web presence, they have IVR system, they have email, there's social, there's a lot of things that I didn't really put in here. And they have all these customers that are really interacting with them in several different ways. Sometimes only on one channel, sometimes intermingling on different channels. Now, to facilitate their own work, this company also maintains some internal information about their customers on their enterprise data, which is their CRM system, their financials. There could be a lot of other internal systems. And so what's really happening is there's these people who are interacting with this company. The company's trying to make sense of what it is that is happening. And you actually see a flavor of this in the big data analytics that pretty much everybody's trying to do today. Like, you know, initially when we started, we weren't sure which domains would be impacted, but we see this pretty much everywhere. In retail and e-commerce, people go on their phone and try to make purchases. People go on the website and try to make purchases. They go in store to return their items. They are interacting with a company over time at different time points. Financial services is the same thing. You're interacting with your bank. You're buying the bank's products. You're buying mortgage products. In the end, it's still fairly the same ecosystem if you look at a very high level. The government also does something fairly similar in many different ways. And we do work with several government customers. Media or the games, like Ted was mentioning earlier, it's the same thing. People are interacting with something, and over time, it is that you're trying to understand what they're doing. One point in time never really tells you what you really need to know. So to speed up the machine learning data pipelines, we realized that what happens is generally, if you look at the entire life cycle of building a model, there's like 4 phases somebody goes through. The first step is getting the data. This is like getting the data from several different locations. You identify what data you want to pull, what are the time periods you want to handle, what type of reductions and transformations you want to apply. There's a lot of iterations that go back and forth in this. And then you want to do your learning. You want to experiment with a bunch of different types of models. You want to check out a few diagnostics. You want to be able to select the best model that you think you can build in the given time frame. And this process, in general, is fairly iterative. This is where the whole exploration process really comes in. Once you've done this and once you've selected what it is that you want to do, then the operationalizing and monitoring is a different phase. That's when you really need to start thinking about what am I going to do for my ongoing data preparation. I built a model today that, let's say, identifies people who are going to make a purchase tomorrow. I did that static analysis, but as soon as I want to put that into production, I have to start thinking, oh, to feed this model, what is that the data that I need to prepare, and I feed it into the system. I need to worry about all the transformations that I applied for learning, and I have to make sure all of those are copied exactly as it is. Am I doing this in a batch manner? Am I doing this in a streaming manner? All of that makes it a lot more complicated. And then let's say even when you actually handle that, there's the next step. Let's say this entire process today, if it takes months, do you really know a model that was learned today is still valid a month down the road? Because let's say today is, as an example, let's say today is October 15th. And a month from now is going to be November 15th. You're gearing up for Black Friday. Your behavior patterns are all over the place. You can't really say that the model I put in production is actually working for me. So not only do you care about your pipeline execution, but you do care about doing a continuous evaluation. Is my model performing as well as what I really expected? And at some point, if you think that the system is actually doing a decent enough job with all the features that you've identified, then maybe I just want my model to relearn. And if it tells me, if my initial model gave me an arc of, let's say, 0.8, and as long as my new model gives me an arc of 0.8, I don't mind. I want to relearn it again because my older model doesn't keep up with the behavioral patterns of whatever the next, this month is, for instance. So this is the entire thing that you really do care about. And so once we broke all of the steps that go into productionizing a model, we were able to figure out a much better way of coming up with a framework that would speed the process up. So some of the key things that we do at Sentosa, I'm glad that Ted mentioned earlier today that metadata is so important, because it's we manage the metadata, and by managing the metadata the way we have, what we found is we can now ask the user to tell us what it is they're trying to do in a business sense. They're telling us, in last 7 days, I want you to tell me number of cart activities. And I'm using that as a feature, for instance. Then we can handle the execution in a much better way. The other thing we do is we actually treat time as a special dimension. Instead of saying time is just a column in our schema, we really go after time as a completely different dimension that we want to use in terms of defining our framework and in terms of defining our components. So then we've built these what we call components that first understand the time. They also understand what it is that we want to do with a specific time. These components now also allow us to provide additional instructions and code on the data that we've prepared. And they also have a little more understanding of the context in which they're running. So the time and code, think of Spark as the framework. Spark does, once you've told Spark that I have this data frame and this is my data source, it may be using some sort of input format. You don't have to worry about it. All you're saying is, this is my data, and I'm running a group by on it, and this is what I want to do. And that's somewhat similar to how we've designed our component. So now our component, you can say, I want you to look at my web data, look at last 7 days, and apply a bunch of transformations that allow me to sum up my cart activities, sum up my product activities, sum up my page views, and even a lot more complicated data transformations. So by doing some of that, we can now define our transformations at a much higher level, start experimenting with it, change it, and actually try out a lot of different things before finally being happy with the model that we have. So to understand how we work with time, I'd actually edited this slide a little bit, but I couldn't use the new slides, but I'll just use this. So in any modeling exercise, what happens generally is that what you're always trying to do is you're trying to predict something, and you want to make sure that whatever you're predicting, all the activity that you've used is completely prior to that. You don't want to have any other signal embedded into whatever prediction you're making. So what we did was we built these, I'll just call it a component or a data set, where, so we have a data set. That data set allows you to say, build me a data set that understands that I'm always going to look back 7 days, or I'm always going to look back 90 days, or I'm always going to look back X number of days. Let's say I'm building a data set that allows me to look back last 7 days for my web data. Then I'm going to build another data set that allows me to look back only last day for, let's say, my IVR activity. And now I want to combine that, and then I want to predict. So prediction is going forward. It's a looking forward. So I want to predict for the next 3 days, is this action going to happen? So now that I've prepared my data sets in this framework, now I can do a very nice mix and match where I can say, now I'm building my features by going over multiple data sets in this framework. I'm combining it with my label that may be looking forward 3 days or looking forward 7 days. And now I want to build my model on top of that. Now, the good thing about this is because we're building these as data sets, I can have one data set that's looking back 7 days, one data set that's looking back 10 days. I can run multiple experiments in parallel, and our system is basically going to get all of that data prepared, and you can run, you don't have to start writing your code multiple times, copy pasting all of these different dates. And the good thing about this is because now you've actually created your data in these sliding windows, you're telling the system that from a business point of view, I want to use last 14 days of activity and want to predict next 3 days. And then as soon as you find a model that works for you, you don't have to do anything because the system already understands what last 14 days means tomorrow. And it will understand that day after tomorrow. It will understand that a month from now. So you don't really have to make any code changes. All of that is actually abstracted under the data set type itself. So I guess I went over the benefits already. But that's basically what I was trying to say earlier. By treating time as a special dimension, now we can start explaining what we're trying to do in a completely different sense. And this is also very useful in other types of analytics. So if you were in the keynote session today that Chris had, where he was saying somebody let's say, bought some tickets to Fort Lauderdale or Orlando, and then later they bought some tickets to Magic Kingdom. At this point, you're still, at that point, you're looking at a customer who's transitioning through different phases in time, and you're really talking about what it is that they did. And that's exactly what our data set is really doing by letting you put these time slices in the picture. And now suddenly we can create a data set where we can say, I want you to look at all the activity I have of this user and put it all together, sequence it by time, and then identify me people who basically bought a ticket, then bought tickets to Magic Kingdom, and their current, let's say their current account balance is XYZ. Instead of you trying to write a lengthy Spark notebook that actually takes you a few hours, you can now do this within less than 10-15 minutes, because now you're defining that within the system is going to run and give you all of that data. So if we go back to the earlier slide that I was showing, so this is how far we came. And now if we put Sentosa in the middle, now Sentosa is, so the business analyst can start using the Sentosa application to, instead of going and directly writing queries, they can now start framing their questions in a more business-friendly terms. The data scientists can start experimenting with the data sets that they're building within Sentosa, which again are sitting in the enterprise data lake. They can start using all the metadata that is being managed by Sentosa to build their data pipelines. And when they're truly done, they don't really have to spend much time basically putting the model in production. In fact, in Sentosa, there's basically just one activate button that you just go and activate. And if this is a batch activate, then they don't even, all they do is they specify a schedule and everything else is just taken care of. On top of that, because this is running within the system knows what it is you're trying to do from a business point of view. It can start doing the monitoring and the maintenance, which is running the scheduled, doing the scheduled relearning over time. So this kind of talks about the same thing, that you basically start with the data preparation where you can do your feature, label, training data preparation. You start, then you move on to your scoring. All of this is basically maintained. You can start configuring it in Sentosa. And because Sentosa really operates on a customer's own big data environment, It's not like this is all data that is behind Sentosa application. This is in your own Hadoop environment or in your own cloud. So all the events, all the data sets, all the model results, everything is in your own platform. So at any given point, you think, oh, Sentosa doesn't give me this very specific oblique random forest, for instance, that I want to use, then you don't have to use everything there. You can basically stop at, let's say, the label, like the data preparation step, and start using your own code from that point onwards. So, like, a lot of times people talk about how doing all of this was simple, and I actually have a different take on it. There were many complications that came up when we were trying to implement this approach. And one of the things that was a big surprise to us was, how there's all these products out there, the modeling products that are out there that talk about how as soon as you built a model using their system, they'll give you an API call, and you could start using that API right away, and you'll be in production. But what we have found is typically, at least in the behavioral use cases, your payload never contains all the information you need to actually apply the model. So let's say I built a model to do purchase prediction for somebody for the next 3 days. And I'm looking at last 7 days of activity they had. You're on a website. The website is not going to give you last 7 days of activity history. The website is just going to do a dip. Give me the prediction for this user. And at that point, you also have to take the real-time activity that's happening. You have to go look at the offline activity that happened in the last 7 days, combine that with real-time, and then apply the scoring on top of that. And that's not as straightforward as just saying that I have a model, I'm just going to convert that into an API, and anybody can score off of that. And then I'd reworded this a little better, but I couldn't really get the new slides in place. There's another thing that we found. Because we are doing this behavioral analytics, we care about looking at data about a customer across an arbitrary time. We can't really say, for today we're only going to look at 1 day, but tomorrow we're going to look at, like, I mean, the time period changes. Sometimes people want to look at like 6 months worth of activity. Like, when you have millions, if not billions of customers, that gets complicated. And unfortunately, the Spark data frame API doesn't give you a very nice way for you to apply a hash partitioner within the data frame API. But a very nice hack was to actually start your data frame by doing a select on whatever the table it is, distribute by the customer ID, for instance. When you do that, then Spark automatically creates a hash partitioner, and then it continues it down, like, down the entire thing. So that has solved a lot of performance problems for us. Then the next thing was a little surprising. Like, Hadoop MapReduce is known to have a lot of small file problems, but Spark doesn't, right? In our experience, what happened is once you use Spark end-to-end for everything, including ingestion, then what's going to happen is the ingestion, to speed up, it's going to parallelize as much as it can. So it's going to create a lot of files. Now imagine you have so many files per day, and then suddenly you have a data scientist who wants to run a model on 6 months worth of activity. A simple count is basically going to blow up the Spark process, because Spark just cannot handle that many tasks. And again, like, another simple hack for us was to, at runtime, identify the number of executors, and then just run a coalesce on that, and that worked wonders for us. And The next thing was, again, this is not worded as nicely, but in our use case, what we found is there's a lot of processes where what we want to do is we want to take a chunk of time period and run a complete DAG through it. So we may be running a bunch of group bys, a bunch of joins that may be causing a shuffle. But because of the way Spark really runs their DAGs, as soon as you have, so if we, to keep our processes optimized, ideally what would happen is one partition would run by itself and it wouldn't really talk to any other executor. And we couldn't stop that per se because as soon as we have any activity that was performing a join or was doing a group by, Spark would basically just do a shuffle across the board. It wouldn't really even understand that we were trying to do some operations only at, let's say, a time partition level. So again, a fairly simple hack for us was to just create a thread pool. And if we were trying to run the process for, let's say, 15 time partitions, have one thread per time partition, run all of our DAGs that we wanted to run in one shot on that thread. And as soon as we were done, we would close that thread. We would we would just go back to the disk and get that data and then run the collective DAGs from that point onwards. And it sounds lame that you're hitting the disk twice, but it actually ended up like giving us more than, like, you know, from I think it was more than like, you know, it cut it off by like 50% or more than that actually. So that was a little shocker. And then the last thing was deploying. So our application runs on all types of Hadoop platform, and it also runs on all the clouds. And so AWS, Google Cloud, Azure, Hortonworks, Cloudera. And we were a little concerned initially at how complicated that could be, but it ended up being, like, we had some nuances, but overall it ended up being a very pleasant exercise that if you're using Spark, then going across the cloud, across multiple clouds, and sorry, being able to reuse your code is not a big deal. Sorry. How are we doing on time? So next, where are we going? Because we have this plug-and-play framework, we can now experiment with adding a lot of other frameworks, embed those into our system at different phases. And we think that we found a very good way of actually being able to embed all of these different frameworks and even different approaches. Our data scientist is exploring a lot of decision theoretic framework or reinforcement learning frameworks that we want to embed in our system. In terms of the data transformations, right now what we have is is something like this, where we have our data sets and you're defining a lot of your transformations in there. But what we also want to experiment with is somebody being able to say, I want to build my own template, and I'm giving you that template in the notebook, and we'll plug that in. Again, it's some things that we're trying. And then we also want to try running on Databricks Cloud. So that's one of the next item that I'm very excited about. But in general, from our business customers, there's a lot of other things that we are also looking at, which is similar to what Chris had mentioned in the keynote earlier, where we want to build a serving layer. Now that we have all of these models that are being built and all of these data sets that we're building, if we had this store where you can start streaming all of those results in, then you suddenly have a very nice serving layer that, that anybody can do a dip or an API. Like he was saying, give me last 30 transactions of this customer. If you care about it, you can define an abstraction like that, and we can subscribe that down into our serving layer. So that's another thing that we're really working on as well. So before I stop, I do want to let you know that we are hiring. We're hiring several positions. We're looking for data engineers, machine learning researchers, machine learning engineers, application developers. So if you're interested in working on any of these things, then please come see us. There's a lot of people at the table as well, and there's enough people here that you can reach out to anybody. Or you can go to sentosa.com and check out our careers page.